Does everybody have a copy of today's class notes? We're going to be meeting in this classroom again on Thursday. So come here again for our next class meeting. And the assignment that I've just given you today, homework 8, that's due on Sunday. I've also posted it online as I try to do. So the PDF of that's online. And that's supposed to say rate of return, not rate or return. Sorry for the typo there. What we're talking about today is rate of return. Specifically, the technical definition of it is internal rate of return. And I'm going to try and refer to it by its full name as often as I can because the internal part, that word internal, means something important and something specific. Before I get into that assumption, internal rate of return is the rate that you're earning on a balance that's unrecovered into an investment. Last time, the reason we met in class was so that you could make the figure of unrecovered investment balance. And you're going to have to do that again on the homework. It's the spreadsheet where we look at over time how much of the original investment has been recovered, how much of each payment is interest versus a return on principal, and so on. So here, rate of return is looking at for how much isn't back to you yet, what is the rate of return on that amount? And what it relies on, the procedure, is that you take the entire cash flow to the present and you find out what interest rate is making the present worth of the whole cash flow diagram equal to 0. So here you can see this cash flow diagram has both revenues and costs. Discount everything to the present, and whatever interest rate will allow everything to come into balance with a present worth of equal to 0, that is internal rate of return. So this figure with the scale is showing it's implying balance. The IRR is what makes the inflows and the outflows in balance. You can only calculate internal rate of return on projects that have a positive cash flow. Today's quiz, for example, has a negative present worth at the interest rate that we had calculated. You can't have a negative internal rate of return, so it can't be calculated for cost-only options. It can only be calculated where there are revenues that are positive. It can be done by hand, but it's easier to do it using Excel or using a graphical approach, and we're going to try all the different methods today just so you can get a feel for it. The whole reason why you do it is to analyze whether a project should be performed or not. And who remembers what MAR stands for? Seems like everybody remembers what MAR stands for. That's good. How is it decided what the minimum attractive rate of return should be? Like how do you know what that interest rate ought to be set at? Okay, I heard people say the weighted average cost of capital. So your borrowing cost is probably one of the biggest factors that goes into determining the MAR. You're not going to say it's an acceptable project if it returns less than what it costs you to borrow the money. There are other factors as well. There's also the availability of other projects. It might be that you have so many good options available that your cost of capital isn't the limiting factor, but what's the limiting factor is simply how many projects you can do at one time with the organizational management and so on. So here in this analysis criteria, what we're saying is we should do the project as long as the internal rate of return is greater than or equal to the MAR, and if it's less than, we shouldn't do the project. So in the activities today, we're going to find what interest rate puts the revenue and the expenses into balance. We're going to discount all of them to the present and solve for whatever interest rate does that. This formula is a summary of that idea. It's saying the present worth will be equal to 0 when the revenue, R, is in balance with the expenses, E. So discounting all of that to the present. Now this graph illustrates what happens when you're guessing the internal rate of return. The correct internal rate of return is the one that has the present worth equal to 0. And you can see that there's a crossover here, and on the y-axis it's showing the present worth is either positive or negative. So if you use an internal rate of return that's too small, that'll give you leftover positive present worth. But if you use an internal rate of return that's too high, then the present worth will be negative. And you can see it's a curved relationship there. It's not necessarily linear. But where the present worth is equal to 0, that's the definition of the internal rate of return. Before we get into the calculations, let me give you a couple of warnings, and these are really important. The first thing is, how do you use internal rate of return? What's appropriate and what's not? It's okay to calculate an internal rate of return and then compare that to your MAR. That's the appropriate use of IRR. It's basically just to say yes or no to one project. What's a little bit more tricky is if you're trying to compare the internal rate of return of different alternatives. Strictly speaking, you shouldn't do that because it is possible that one project will have a higher rate of return, but it's actually not the best project than the other one. And the reason why that could happen is maybe one of the projects is smaller. And so if you do a very small project, it has a high rate of return, but your initial investment was so small that maybe you're not getting the maximum profits. And so what you want to do is you want to maximize profit, not maximize your rate of return. It's better to have a really big investment with a medium rate of return than a very small investment with a high rate of return, because the bigger investment with the medium rate of return would give you greater profits. So the main thing to realize for now is don't simply compare two different IRRs for two different projects and assume that that's going to tell you which project is best. Another warning, besides don't compare them, here in bold, you can tell it's important because it's bold. The internal rate of return assumes that whatever cash is generated from a project is going to be reinvested in that project. So if you bought a truck and you paid some money at the beginning and now you're getting revenue from that truck, if you calculated the internal rate of return, what it's assuming is that anytime you get profits and revenue from your business, you take that money and you reinvest it in the business. And so whatever revenue you get, somehow you're reinvesting that into the truck so that you can make even more money in the future. Sometimes that's possible, like with a bank account, you can take your profits and you can put it right back into the bank. But some businesses, it's not possible to reinvest whatever revenue you have into the business again. And so we have to use a different alternative to calculate rates of return in those instances. But IRR assumes that you're going to take your revenue and put it back into the business. So keep that warning in mind. I'd like you to get started on this cash flow diagram. In the in-class exercise for today, I give you a cash flow diagram, and using Excel, what you should do is discount everything to the present with 7%, and then discount everything to the present at 8%. You'll get the numbers, fill in the blank there, and then proceed with part 2, because in part 2 it's asking you to do linear interpolation. And let me write the idea for linear interpolation on the board, just to summarize again what we're doing. Do both, 7% and 8%. Let's take a look at the linear interpolation. Okay, so we know 7% gives us a positive value and 8% gives us a negative value. By the way, the way to think about that is if you could borrow money at 7%, then you're going to make $26,000 profit on this business. So if you had to pay the bank 7% to borrow the money, and then you did this project, it's still going to be profitable for you. But if you had to borrow the money at 8%, so you're paying the bank 8% interest, then it means you're going to lose money by doing this project. You shouldn't do this project if you have to borrow the money at 8%. So that's one way to think of it. What we're trying to do is find the internal rate of return, and so the interpolation is shown both on the screen and on the whiteboard there. You're looking for how much is the amount changing per percent. So we go from the positive value to the negative value, the difference in that increment, and the difference between 8% and 7%. So there's $41,980 during that percent range, and to go from the 7% to the crossover point is 26,000. So just by thinking about it, we know that it should be further away from 7 than it is to 8, because the 7% was further away from 0 than the 8% value was. And so this kind of makes sense that it's 0.64. That means 7.64%. When we do the linear interpolation, that is that's the rate of return, the internal rate of return that we calculate. All right, in part 3, use goal seek. So you've already tried 7% and you found the present worth, and you tried 8% and you found the present worth. Think about how you'd use goal seek in order to find out the present worth is equal to 0 at what percentage. All right, let's take a look at goal seek. I think almost everyone remembered it pretty well. What we're doing in goal seek is we have the same cash flow that we did before, and we have to start with a guess value for the interest rate. So like if it was 2%, then it's too high. If it's 9%, then the present worth is too small. So what we want to do is data, what if analysis, goal seek, and our objective is we want this sum to be equal to 0, and we want it to accomplish that by changing where the interest rate is written. And so it changes that around a bunch of times, and it finds it's 7.633%. All right, the IRR function, it's really nice, but there's one warning I'm going to have to share with you after I show you how to use it. Okay, so we have this cash flow function here, then I'll just do equals IRR and then highlight the original values. I'm not highlighting the present worths, I'm just highlighting the original values, and then I can press enter and it finds, well, here it's formatting it as money. Let me change it so that it's formatting it as numbers. And it's saying 0.0763, which was the same as when I did it by the goal seek method. The thing I want to warn you about IRR is, how does it do that? You know, it's got the amounts, but it seems like that wouldn't be enough for it to do its calculations, right? It's doing something else. In addition to looking at the amounts, it's also looking at what order they come in. And it assumes that the number at the top of your range is your 0, and then it assumes that at the bottom of your range is how many years there are. So it's counting the number of them, and it's considering the order as well. So you couldn't put year 8 at the top and year 0 at the bottom and get a correct IRR value from that. The other thing is you can't skip years. So if there's a year in your cash flow diagram where nothing happens, you need to enter 0. You can't just leave it blank, because it would skip over the blank in the range. So that's a hint for the homework, is when you're using the IRR function and there's a year where nothing happens, enter 0 on the cash flow diagram. Okay, so question 5, I'm asking you to offer a short answer there. Explain why in part 2, our linear interpolation, we got 7.64, but then both of the Excel methods, it got 7.63. So think about that quietly to yourself. Write it on the paper, and I'm going to put a hint on the screen here. This image is a hint on why there's a difference between what you did with the manual linear interpolation and with Excel. So again, you can see that this is curved, but in the linear interpolation, we assumed that it was a straight line.